let's talk related rates. A water tank has the shape of an inverted circular cone with a base radius of 2 and a height of 4. If water is being pumped into the tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising when the water is 3 meters deep. Okay, let's relate some rates. What are the rates that we're interested in? Well, they give us the rate that water is being pumped into the tank, and that is 2 meters cubed per minute. So this volume of water is changing, right? So our dV dt is going to be equal to 2 meters cubed per minute. What are we interested in? Well, we're interested in the rate at which the water level is rising at a certain point when the water is 3 meters deep. So that's going to be how our height is changing, our dH dt. We want to know what that is at a certain point, right? Because the water rate is changing at different heights, right? So they want to know particularly what the dH dt is when our height is equal to 3. Okay, let's find an equation that relates my volume variable to my h variable. What will do that? Well, I think the volume of our cone will do that. So the volume of a cone is going to be our v is equal to 1/3 pi times r squared times h. And we've got this little r floating around here. We are not really concerned with her. So what if we found a relationship between our radius and our height, and then just put our r in terms of h? And we can do that using similar triangles, right? We've got a triangle right here, and then a triangle right here. So let's use proportions. We know that r over h is equal to, let's see, 2 over 4. Okay, we've got an expression that relates r and h. Let's now solve that for r. So if we multiply by h on both sides, and 2 over 4 is just 1/2, we're going to have our r is equal to h over 2. Okay, let's plug that back into our volume equation. So we've got that our volume is equal to 1/3 times pi times r squared, which we're subbing back in. So we've got h squared over 4 times h. Let's clean that up a little bit more. So we've got 1 over 12, or we could even say pi over 12 times h cubed. Okay, we've got our equation, and we've got how our volume and our height are related, but we want to make our dV dt and our dH dt appear. So what can we do to this equation? Well, we can differentiate on both sides with respect to t. So this is going to turn into dV dt, and then on my right side, I'm going to be very careful. I'm going to use my chain rule, so I'm going to have pi over 12 times 3 h squared times dH dt. And if we clean that up a little bit, we're going to have dV dt is equal to pi over 4 h squared times dH dt. Okay, our whole goal is to try and solve for that dH dt at a certain point, right? When h is equal to 3. So we have our dV dt, we have our h. All we need to do is solve for our dH dt. So let's plug and chug. We've got 2 meters cubed, so that should be equal to pi over 4. We're solving for when our height is equal to 3, so we're going to have 3 squared, which is times 9, times dH dt. Solve for that dH dt, and what are we going to get? I think we'll get, let's see, divide by 9 on both sides times 8, so 8 over 9 pi, and so our height is changing at a rate of 8 over 9 pi meters per minute. Related rates.